All right, this one, proving triangles are similar. It's the same type of deal as when we proved triangles were congruent using SSS, SAS, ASA. Difference now is it's for similarity. So there are two that work added to, remember, if two angles are congruent, then both triangles have to be similar. So SSS, the difference here is before all three sides had to be congruent. For similar, all three sides have to be proportional. So you just check to make sure AB over PQ, does that equal BC over QR? Does that equal AC over PR? So you got to check to make sure they're all proportional. The side angle side is you only have to check two sides to make sure they're proportional, and then the angle in between those two sides has to be congruent. And then again, don't forget about the third one that we did yesterday. It's angle. So here we got three triangles. Two of them are similar. You got to figure out which two. Now we don't know any angles, so angle doesn't work, and neither does side angle side. So we got to check SSS. Now these you can kind of look at to see which ones you think they are, and then just figure it out. To me, it looks like it'd be these two. So you got to find the proportions. The short side to the short side is 4 to 6, which reduces to 2/3. So check to see if the other one's reduced to 2/3. This is the long side, and this is the long side. 10/15 does reduce to 2/3. And then the middle side to the middle side, 8 to 12, you can divide them both by 4 and you'd get 2/3. So it is these two, so then you got to write the similarity statement. Triangle QRS is similar. So Q is the same as T. R is the same as V. And then the last one is a W. Now, the way you can tell that is R is in between the shortest and the middle side. So you choose the letter that's between the shortest and the middle side. Okay? So part of our problems are like this, where you'll be given 3 triangles and you got to find the 2 that are similar. Another one is like this. I think it's going to be these 2. So if we check the short side to the short side, you can divide them both by 3 and you get 4/5. The long side to the long side, 20 to 25, you can divide them both by 5 and you'd get 4/5. And then the remaining 16 to 20 does reduce. You can divide them both by 4 and you'd get 4/5. So it is these two. So you write the similarity statement. Triangle KLM is similar. Now K is between the longest and the shortest, so that would be N. L would be the same as P, and then Q is the last one. So that's the side, side, side. Here we got a side angle side. Here, if I drew these two separate, it'd be easier to see. We have MRN, which this is 12, this is 90, and the whole side is 10, so this would be 8. And then the big triangle, again we have 2 angles that are the same. This is 10 and this side is 15. So the side angle side we can check. We know the angles are equal. This is 10 to 8, which is 5/4, and this is 15 to 12, which you can divide them both by 3 and you get 5/4. So they are similar. So the reason is just SAS. They already put the similarity statement right there. Now, technically we could have did something different here without even using the sides. Since this is perpendicular to that and this one's perpendicular, what do you know about these two lines? They're parallel. So then what do you know about this angle and that angle? They're corresponding, so they're the same. So we could have used angle would also work on this one, because we know the two angles, these two and these two are the same. Okay, so just like we did before, when it says describe how to prove it, we only have 3 things to choose from today. Obviously it could be no, but it can be angle, all 3 sides are proportional, or 2 sides and the angle in between. So in this one, I know that's congruent, so it's probably going to be SAS, but we got to check to make sure because some of them are no. 15 corresponds to which one? 18, yeah. So I can reduce those by 3 and I get 5/6. 20 to 24. 4 goes into it, yep, 5/6. So it is, so the reason is SAS. Okay? Then also there's some where you gotta find, I'll put it up there and show you, but using proportions to find the missing side.